my friend Elmo.
Hi, Kaylee.
Hi, Elmo.
What is Kaylee doing in Elmo's class?
I'm here today to teach you about calculus.
Elmo loves calculus.
I love calculus too, Elmo.
What are we learning today, Kaylee?
We're going to learn about the limit definition of the derivative.
Wow, Kaylee, that's a lot of big words for Elmo.
It sure is, Elmo. Let's get started. First, we need to know the formula, which is the limit as delta x approaches 0 is equal to f of x plus delta x minus f of x all over delta x. And this formula represents the slope of the tangent line. So let's try some examples. Number 1, f of x is equal to negative x squared minus 3x plus 1. So we plug this into our formula, which is the limit as delta x approaches 0 is negative x plus delta x squared minus 3x plus delta x plus 1 minus negative x squared minus 3x plus 1 all over delta x. Now we simplify this to negative x squared minus 2x delta x plus delta x squared minus 3x minus 3 delta x plus 1 plus x squared plus 3x minus 1 all over delta x. Then we can cross out x squared and negative x squared, negative 3x and 3x, and 1 and negative 1. So we get negative 2x delta x plus delta x squared minus 3 delta x all over delta x. Then we can factor out a delta x and we get negative 2x plus delta x minus 3 over delta x, which cancel out. Then we know that the limit of delta x as approaching 0 is negative 2x plus delta x minus 3. Then we plug 0 in for delta x, so we get negative 2x plus 0 minus 3. And we get negative 2x minus 3 as our answer.
Wow, Kaylee, can you show me more?
Sure, Elmo. Let's try another one. Okay, problem number 2 is f of x equals cosine x. So we use our formula, limit as delta x approaches 0, it's equal equal to cosine x plus delta x minus cosine x all over delta x. Then we get cosine x cosine delta x minus sine x sine delta x minus cosine all over delta x. Then we can split this up into negative cosine x times negative cosine delta x plus 1 over delta x minus sine x sine delta x over delta x. Then we know that this is equal to 0 and this is equal to 1. So then we get the limit of delta x approaches 0 as negative cosine x times 0 minus sine x times 1 and get negative sine x as our answer.
Wow, Kaylee, you're really smart. I think I want to know one more.
Okay, let's do one more problem, Elmo. Okay, number 3. F of x is equal to x plus x over 2. So we use our formula to get x plus delta x plus delta x over 2 minus x plus x over 2 all over delta x. Then we need to simplify to get 2x plus 2 delta x plus delta x minus 2x minus x all over 2 all over delta x. Then we can simplify this even more because 2x and negative 2x can cross out, x and negative x can cross out. So then we get 3 delta x over 2 over delta x. Then we can flip to get 1 over delta x. So the delta x crosses out and we get 3 halves as our answer. And that is how you find the derivative using the limit definition, Elmo.
Wow, Katie, that looks really hard.
No, it just takes lots of practice and studying. And you have to remember the formula is the limit of delta x as it approaches 0 is equal to f of x plus delta x minus f of x over delta x.
Okay, Kaylee, thanks for coming to Elmo's class and teaching me about calculus.
Thanks for having me, Elmo. See you in calculus class.